Welcome back, students. Okay, what we're going to look at here are some equations that include brackets and show you an alternative way of solving such equations. Okay, first off, just a quick reminder that here are the steps for solving almost any linear equation. And what you learned first is step 3 is using AMIB, add and subtract first, multiply and divide next, etc. Solving 1, 2, and 3-step equations using that. In the last video, we showed you what to do if the variables on both sides. And in this video, we're going to show you how to solve equations where the first step is going to be to simplify the left-hand side of the equation. So let's have a look at the equation here on the left. Now I've got 3 multiplied by all of y plus 4. So I certainly could divide both sides by 3, undoing multiplying by 3. But the problem with that is I end up with a fraction. And then to solve it, I then have to work with a fraction. Now there's nothing wrong with that. And if you do it correctly, you'll get the right answer. But in general, if we can avoid working with fractions until the very end, it's usually a good thing to do so. So I'm going to go ahead and delete what I've just done, and I'm going to solve this equation differently. So what I'm going to do is get rid of the brackets by multiplying using the distributive law. So this is 3 times all of y plus 4, which means 3 times y plus 3 times 4. And now that I've removed the brackets, I can just go ahead and solve it as we've learned previously. Subtract 12 from both sides. Add 12, subtract 12, cancels out. That leaves just the 3y on the left. 11 subtract 12 is -1. Divide both sides by 3. So notice we do end up with a fraction, but we got it in our very last step. And that's where we want it. So the answer is y equals -1/3. We could go ahead and check that by substituting that in place of y. My suggestion is just, that's a bit tricky to do. My suggestion is just follow through the steps very carefully. Or alternatively, if you have a calculator, you could put -1/3 into that and see if you do get 11 for the answer. Okay, let's look at a second example. Now in this case, I could divide both sides by 2, and that would probably be the easiest way to do it. But in this case, because I'm practicing the idea of expanding the brackets, I'm going to do it this way. So keep in mind, there's often 2 or more ways to solve equations. I'm just showing you one way. There are alternatives. So in this case, you could divide both sides by 2 and carry on from there. I'm going to solve this one by expanding out the brackets. So 2 times 10 is 20. Change that to plus and negative. So plus 2 times -2p is -4p equals -8. Okay, so I've got -4p plus 20. So now I can subtract the 20 from both sides, like so. That leaves me just the -4p. That leaves me with -28. Last step, divide both sides by -4. Those cancel out, and p is -28 divide -4 is +7. Okay, let's go ahead and check this one. 2 times 7 is 14. 10 take 14 is -4. 2 times -4 does give us -8. So a quick check shows us that we do have the correct answer. Okay, time for you to have a go at these questions. Once again, with the second one, if you want to, you can divide both sides by 3 first, but why don't you practice expanding out the brackets? Okay, turn off the video and come back once you've finished. Okay, welcome back, students. Okay, once again, I'm going to change every subtraction to add the negative. I'm going to multiply 2 times the y and 2 times the negative 6. That's called the distributive law. 2 times y is 2y. 2 times negative 6 is negative 12. Equals 7. Adding negative 12, the opposite of that is adding positive 12. Negative 12 plus 12 goes to 0, leaving just the 2y on that side. 7 plus 12 is 19. Divide both sides by 2. And final answer, y is 19 over 2. And if you prefer, that's fine to leave it like that, but if you prefer, 2 goes into 19 9 times with 1 remainder. So you can also leave it as a mixed number. So once again, you could have divided both sides by 2. That's still a correct step, but that gives you a fraction, and then you have to work with a fraction to finish it off. Similarly, in the second equation, you could divide both sides by 3, which is probably a good way to do it because the negative 6 divided 3 doesn't leave a fraction. But I'm going to do this just to give more practice at expanding brackets. I'm going to do it by expanding out the brackets first. So 3 times 6 is 18 plus 3 times negative 5p is negative 15p equals negative 6. Okay, I've got negative 15p plus 18. So first thing I do is I subtract the 18 from both sides, like so. They cross out. That leaves just the negative 15p equals negative 6 subtract 18 is negative 24. Okay, my next step is to divide both sides by negative 15. And negative 15 divided negative 15 is 1, so I end up with 1p, or just p. Negative divided by a negative is a positive, so I get 24 on 15. And then what I have to do now is simplify that. So I can divide top and bottom by 3. 3 goes into 24 8 times. 3 goes into 15 5 times. And that ends up being 8 over 5. Or if you prefer mixed numbers, 1 3/5. Once again, it's too difficult to substitute that into there and find out if the equation works. So just to check it, work through the steps a second time, or if you have a calculator, substitute 8/5 in for p and check it that way. Okay, so that's the videos on what we do if we have brackets on one side of an equation. Again, you can go ahead and divide both sides by the number outside the brackets, and sometimes that is the best way to do it. Alternatively, you can always expand the brackets and continue from there.